Hello students, I am recording this video because I would like to explain about the systems of linear equations, uh, and I will also explain at the end an example of a system of nonlinear equations. So first, talking about systems of linear equations, we have that a system of equations is basically a collection of two or more equations, each containing one or more variables. Now, the solution of a system of equations would be the values of the variables that are solution of each of the equations that are part of the system. So basically, when you find the solution of a system, these solutions have to satisfy all the equations of this system. To solve a system of equations is basically to find all those solutions of the system. In the case of the systems of two linear equations into variables, you graph the equations, you can find the following scenarios. You can find the first scenario where the lines are intersecting at one point. If you find the x and y coordinates of that point of intersection, in that case, the coordinates, the values that you find are going to be the value of x and the value of y that you find are going to be the solution of the system. So the solution are just the coordinates of this point of intersection. In this case, you say that the system have one solution, the system is consistent, and the equations are independent. There is a second scenario where the equations are parallel, so these equations are not intersecting. So in this case, this system have no solution, and we say that the system is consistent and the equations are is inconsistent and the equations are independent. So this one is inconsistent and equations independent. And you have a last case, that is when you have coincident lines. That means one line lies over the other, right? In this case, the system have infinite solutions. So remember, first case, you have a system that is consistent and the equations are independent. Here you have a system that would be inconsistent because they have no solution, and the equations are also independent. And here we have one case where the system is consistent because it has solution, but the equations are dependent. It's basically two equivalent equations where you have, right? So that's why they have or they share the same graph. Now let me give you some examples of solving systems of linear equations. In this first case, instead of solving, what we're going to do is to check if a given values of x and y are solution of a given system. So they say verify that the values of the variables are solutions of the system of equations. They give us the equations 2x minus y equals 5 and 5x plus 2y equals 8. And the solutions they ask you to verify are x equals 2, y equals minus 1. So in an exercise like this one, what are we supposed to do? We're going to substitute x and y, into both equations, and we're going to see if we get true statements. So we get the first equation, 2x minus y equals 5. We know that x is 2, so we say 2 times x, which is 2, minus y, which is y, minus 1, equals 5. So 2 times 2, 4, minus negative 1 is going to be positive 1, equals 5. So 5 equals 5. This statement is true, that these two values, 2 and minus 1, values of x and y, satisfy the first equation. Now, to be solution of the system, they have to satisfy also the second equation. The other equation, which is 5x plus 2y equals 8. So we substitute x by 2, 5 times 2 plus 2 times y by minus 1 equals 8. 5 times 2, 10. 2 times negative 1, negative 2, this is 8. So 8 equals 8, which is also a true statement. So since we got two true statements, right, we can now say that yes, 2 comma minus 1 is solution of the given system. If the statements are false, or if one of the statements is true and the other statement is false, then in that case the order pair given is not solution of the system. So the values of x and y that were given are not going to be solution of the system. To be solution, to know the values of x and y must satisfy all the equations. If it's a system of two equations, both equations. The next exercise is just to an exercise we're going to solve the equation, the system of equations, but in this case we're going to use substitution. Substitution is a method where the first must be to isolate one of the variables from one of the equations. I will just call my equation 1 and equation 2. I will solve for any of the variables in any of the equations. I look at my equations and I find very convenient to solve for y in equation 1 because the coefficient of the y is 1. There is no number here in front of the y. There is no numerical factor in front of the y. It's because its coefficient is 1. So when I solve for y, I don't get a fraction. So I will solve for y in equation 1. When I solve for y in equation 1, I get 5x minus y equals 21. So minus y equals subtracting 5x from both sides, 21 minus 5x. So y is equals multiplying both sides by negative 1, positive 5x minus 21. When you have the value of y, you will substitute y by x expression in the other equation, so in this case in equation 2. So we're going to substitute y by x equation by x expression in equation 2. Equation 2 is 2x plus 3y equals minus 12. So we say 2x plus 3 times what is y, 5x minus 21 equals minus 12. Now we apply this distributive property. 2x plus 3 times 5x is going to be 15x. 3 times negative 21 is going to be negative 63 equals negative 12. Combining similar terms, we get 2x plus 15x is 17x minus 63 equals negative 12. Adding 63, 17x is equal to negative 12 plus 63. 17x is equal negative 12 plus 63 will be 51. So we divide by 17 both sides. X is equal to 51 divided by 17. And then x equals 3. 3 times 7, 21. Carry 2. 3 times 1 is 3. And 2 is 5, 51. So x equals 3. So we have that one of the possible solutions here is 3. Now, when I solve for y in my first step, I got this equation that I can call equation 3 if I want to. That is very important because it let me find y easily. Once I found the value of x, now I have to substitute x in this equation 3 by x value, and I will get easily, the value of y. So we substitute x by x value in equation 3. So what is y? Y is 5x minus 21. So y is equals 5 times 3 minus 21. Y is equal 15 minus 21. Y equals minus 6. Well, we have now the solutions. 3 and negative 6, x equals 3, y equals negative 6, but we must check. So we're going to check to make sure that these are really the solutions, that we didn't make any mistake. So for first equation, 5x minus y equals 21. I say 5 times 3 minus negative 6 equals 21. This is 15 plus 6 equals 21. So 21 equals 21. This is true. So we're good with the first equation. Now we do the same for the second equation. So we have 2x plus 3y equals negative 12. So it's 2 times 3 plus 3 times negative 6, sorry, plus 3 times negative 6 equals negative 12. This is 2 times 3 is 6, minus 18 equals negative 12. So negative 12 equals negative 12. This statement is true. So now we know that the solution is the order pair 3 comma negative 6. This is the solution of the system. And this system was solved by substitution. Let's now solve the next system. And this is a system that we're going to solve by elimination. Now to solve a system by elimination, we're going to eliminate one of the variables. You will eliminate, or you can eliminate any variable, whatever you feel is more convenient. In the system that is given, it's very easy to eliminate the variable y if I multiply the first equation by 2, and that's basically what I'm going to do. So we say 2x minus y equals 0. But if I multiply this equation times 2, because you can multiply any of the equations by any number, or you can multiply both equations by different numbers at the same time. So you can do multiple transformations, right, in order to do the elimination. So in this case, it's going to be enough to multiply this equation by negative 2. So we get that by positive 2, that 2 times 2x will be 4x. 2 times negative y is going to be negative 2y, and 2 times 0 is 0. So my first equation now becomes 4x minus 2y equals 0. So I will call this equation equation 3, right? Because it was an equation that I got after making a transformation to equation 1. So adding 2 and 3. We get 4x plus 2y equals 12. 4x minus 2y equals 0. 2y minus 2y, that would be 0, and then 4x plus 4x is 8x. 12 plus 0 is 12. So we got that 8x is equals 12 divided by 8. X is equals 12 over 8. Now both are divisible by 4, so x is equal to 3 over 2. So I have now the value of x. We're going to now find y. To find y, we can substitute xy's value in any of the equations. So I'm going to, in this case, do it in equation 1. So I have my equation 1 is 2x minus y equals 0. So it's 2 times, what is x? 3 over 2 minus y equals 0, right? I will simplify here. So I get 3 minus y equals 0. I will solve for y. So we say 3 is equals to y, or y equals 3. So it looks like the solution is going to be 3 over 2 comma 3, but I will check my answer to make sure that it's okay. For my first equation, 2x minus y equals 0, I say 2 times 3 over 2 minus 3 equals 0. 2 and 2 here cancel out. So you get 3 minus 3 equals 0. So 0 equals 0, which is true. For the second equation, I have 4x plus 2y equals 12. So it's 4 times 3 over 2 plus 2 times 3 equals 12. 4 times 3, 12 over 2 is going to be 6, plus 2 times 3 is going to be 6, equals 12. So 12 equals 12, which is true. As I got two true statements, now I know that the solution in this case is 3 over 2 comma 3. That is the solution of my system. And this was solved by elimination. Here we have a very simple application problem. They say the perimeter of a rectangular floor is 90 feet. Find the dimension of the floor if the length is twice the width. So we have a rectangular floor. This should be the length. This should be the width. L is length. W is the width. Now, what we know that perimeter of a rectangle is 2 times the length plus 2 times the width. Because the perimeter, remember, that is the sum of the sides of the geometric figure. In this case, this is a rectangle. But they say that this perimeter is at the same time 90 feet. So I can say that 90 is equals to L plus 2W. And this becomes our first equation. What else is given? They say that the length is twice the width. So the first equation came from perimeter of the rectangular floor is 90 feet. So this is the origin of the first equation. Now the origin of the second equation is this other part that say length is twice the width. So when they say the length is twice the width, remember that twice means 2 times. So I say L is 2W. And that is the second equation. That means that we have two equations now. So I have a system that is 2L plus 2W equals 90, and another that say L is equals to W. I will solve the system by substitution. So this is my equation 1, equation 2. I will substitute L by x expression in equation 1. So L is 2W, so I say 2 times 2W plus 2W is equals to 90. This is 4W plus 2W equals 90. This is 6W equals 90. This is W equals 90 over 6. So W equals 15, and now we know what the units are, so it's feet. So W is 15 feet. Now we're ready to find out, so we substitute W by X value into equation 2. L is equals to W, so L is equal to 2 times 15, so L is equal to 30, and the unit is feet. So now we know that the solutions are: the width is 15 feet, the length is 30 feet. So we found the dimensions of the given rectangle. The next exercise that I want to explain is a system of nonlinear equations. So we have two equations now here, but one of the equations is a nonlinear equation. In this case, the second equation. The first equation, y equals 2x plus 1, is a linear equation. The second equation, 2x squared plus y squared equals 1, is a nonlinear equation. So how can we solve a system of nonlinear equations like this? Well, in this case, I will do it by substitution, and I substitute y by x value by x expression in equation 2. So equation 2 is 2x squared plus y squared equals 1. But y is 2x plus 1, so we say 2x squared plus, what is y? 2x plus 1 squared equals 1. So 2x squared plus, and then we are going to find the square of this binomial, which is the square of the first, 2x squared, which is 4x squared. 2 times the first times the second, so 2 times 2x times 1, which is 4x, plus the square of the second, so 1 squared, which is 1. 2x squared plus 4x squared is going to be 6x squared plus 4x plus 1 equals 1. If we subtract 1 from both sides, we now get that 6x squared plus 4x is equal to 0. So we have this quadratic equation that we need to solve. I will just solve by factoring 2x out because it's the greatest common factor. When I factor 2x out, I get 3x plus 2. So 2x times 3x plus 2 equals 0. Double check. 2x times 3x, 6x squared. 2x times 2 is 4x. Now use the zero product property and say that 2x equals 0. So x is equal to 0 over 2. So x equals 0. Now 3x plus 2 equals 0. So 3x equals negative 2. So x is equals negative 2 over 3. So we have two values of x. Now we're going to find the values of y. So when x is 0, y equals 2x plus 1. So y equals 2 times 0 plus 1. So y is equals 2 times 0, 0 plus 1 is going to be 1. So we're going to have one solution that would be 0, 1. Now when x is negative 2 over 3, y is equals 2x plus 1. So we are just now substituting the values of x into equation 1, right? So y is equals 2 times negative 2 over 3 plus 1. Y is equals negative 4 over 3 plus 1. I will express 1 as 3 over 3. So y is equal to negative 4 over 3 plus 3 over 3 to be able to add the fractions. And negative 4 over 3 plus 3 over 3, we get that y is equals to negative 4 plus 3 over 3. So it's negative 1 over 3. That means that your second solution would be negative 2 over 3, comma, negative 1 over 3. So in this case, this system have two solutions that are 0, comma 1 and negative 2 over 3, comma, negative 1 over 3. I recommend you know that if you want to verify these solutions, in addition to just substitute x and y by their values, more than verify, you want to visualize, right? Why are these solutions? You can use, as I have explained in other cases, the website desmos.com. You can graph the equations and you look for the points of intersection and verify if these are really the solutions. Thank you for the attention. I hope the video was interesting for you, and I hope to see you in a future video.